Hi, everyone. Welcome. Thank you so much for joining us today. It's a real pleasure to be in London. Too many KubeCons have been in other wonderful countries, but it's great to be here. If you're joining us from overseas, go to the Barbican, go to the South Bank, go get some beer. It's a great place to be, especially in this lovely weather. But I'm delighted you've joined us in this dark, cold room to talk about K8sGPT. It's a real testament to your effort, so thank you very much for that. We're really excited to talk to you about K8sGPT today, because there's going to be a portion of the room that's never heard of it, there'll be a segment of the room that might have heard of it, and there'll be a few people that have probably used it in a bit of anger. What you probably don't know is there are a bunch of companies assisting us behind the scenes to make it better and better, on-prem, in the cloud, for single operators, and for entire teams. And we believe that it's having a very subtle yet profound impact on the ecosystem for platform engineering and beyond. So let me introduce myself. My name is Alex Jones. I'm a principal engineer at AWS, but I'm speaking about my beloved project that I started 2 years ago out of frustration of being an SRE, wanting to effectively codify Go tests into slightly more integration-y tests, and that eventually evolved into a suite of behavioral tests that eventually was the start of K8sGPT.
Good afternoon, everyone. My name is Anais Urlichs. I'm a platform engineer at the accelerator at JP Chase here in London. Now, anything I'm sharing within this presentation has nothing to do with my employer or my day-to-day work. To get started, I want to ask you a few questions. Who here is using cloud-native open source technologies within their stack? Hands up. OK, most of you, I assume,
I hope so.
if you're at KubeCon. Now, what technologies are you most excited about? Just scream it.
K8sGPT.
What else?
Envoy, Prometheus, Kubernetes.
What are you excited about? Tell me. OK, I hope at the end of this presentation, you will shout the next time K8sGPT. Now, who here, last question, who here is working or has experience working in a highly constrained, regulated environment, an industry where you have to ensure that you are abiding by the regulations within the industry? OK, several. Cool. Now, a lot of times, when we as engineers identify new toolings that can help us within our job, within our day-to-day, make our lives easier, it can be very difficult to convey that information, the value of those, to the company, to the organizational goals. Here are some of organizational goals that you might want to work towards, that most companies are working towards, which is that we want to reduce the time to market, we want to maximize developer efficiency, and we want to maximize cost savings. Now, our tooling, the tooling that we're choosing, have to contribute to these goals on a day-to-day as well as long-term. Some of these goals have been achieved by other companies by restructuring their existing processes as well as the way they structure their teams. So many companies have moved to a centralized platform engineering team. Within your company, it might be called a DevOps team. It might also be part of an SRE team. Generally, their responsibilities is to provide reusable tooling, reusable services, infrastructure components to other engineering teams. The goal is that engineering teams can independently spin up new infrastructure resources on demand with little to no interaction from the platform engineering team. That's the goal. So we want to scale ourselves out of our job to ultimately maximize efficiency within our workflows and not linearly scale our platform engineering team alongside of our workloads.
Do more with less, right?
To make this happen, however, our tooling has to evolve as well, not just our processes, not just the way that we structure our teams. So our tooling has to become a lot more autonomous and rely a lot less on human interaction to, for example, fix bugs in a manual way. Now, we see this kind of trend in other areas in the cloud-native space, such as, for example, in the GitOps space. If you've been here yesterday at ArgoCon, you might have learned more about Argo CD as a GitOps tool. We also see it in new infrastructure as code tooling that you can use from within your clusters, such as Crossplane, that allow more or less deterministic setup of all your infrastructure resources. Now, this all sounds amazing, to basically build zero-touch environments that just scale yourself out of the job so you can focus on your long-term goals. But it's obviously not that easy, otherwise we wouldn't be talking about it. There are lots of challenges that we have to overcome. And one of them is that as a platform team, as we are choosing the technologies that we want to implement in our infrastructure, we ultimately make other teams dependent on us because we are going to be the most knowledgeable about those infrastructure components. Meaning if specific components within a specific environment, one of your maybe a few hundred clusters breaks, it will either be very time-consuming for other engineering teams to identify the root cause, or they will have to pull in people from your platform engineering team to help out. Additionally, we can all agree on that this environment that we operate in is highly complex. There are lots of moving parts, and it's really difficult to stay up to date. So you might not have multiple people across your teams or within your platform team who are very knowledgeable about a component. It might even be set up by a single individual, meaning if that person leaves, their knowledge, their tacit knowledge and experience over time is not necessarily transferred to other people. They might leave some documentation, some runbooks, but who knows where they are and how to use them and in what situations they would be applicable. And that can result in long-term tech debt for your organization, and you might even end up operating your once ideal zero-touch environment as a black box until things just start falling apart, and you have to pull in an external consultancy to fix things. Now, that can also then result in organizational challenges. One of them is, how do we stay compliant within our infrastructure? How do we provide consistent operations to all of our distributed teams? Another issue is if we are operating our infrastructure kind of as a black box, or half of the people who are operating the stack don't know most of the components. How do we ensure that our mission-critical applications are reliable and available? Now, this is exactly where K8sGPT comes in. Imagine having an expert Kubernetes SRE on call 24/7. That's K8sGPT. It was started in 2023, then donated to the CNCF and is a CNCF sandbox project. Now, although it's completely community-run, there are several household names who are using it and have contributed to this talk. How does K8sGPT work? It's basically a technology that allows you to scan your Kubernetes cluster using AI-enhanced analysis on codified SRE knowledge to debug and triage issues across your environments in simple English. Once that has done it, you will be provided with measured guidance on how to fix those issues. It's basically your dependable sidekick operating across your environments to identify the health of them. All the way from knowing what is actually running across your environments, how does it work, what could break in those components in your custom providers that you might be running, all the way to remediation. That's where K8sGPT comes in. Now let's look at K8sGPT superpowers. K8sGPT comes in a number of different formats. You can either use the CLI, the operator, in server mode or interactive mode. Wherever you are, whenever you are, we let you use K8sGPT to identify your cluster health. It also comes with 11 different interoperable AI backends, meaning you can choose between Hugging Face, OpenAI, Bedrock, or even bring your own models, whatever provides you with your most accurate data. In the same spirit, you can also build your own custom analyzers. Now, analyzers in K8sGPT are that component that tell the tool what is a pod, what is a deployment, how does it work, how can those go wrong, or in your specific environment, what are the components that are unique to you and your setup. That's what you build into custom analyzers. We have several of our enterprise partners using custom analyzers to build this private knowledge into and integrate it into their infrastructure, their machines, their data centers. K8sGPT comes also readily integrated with Prometheus, so you can look at the K8sGPT metrics alongside all of your other metrics in the same dashboard and correlate them. Now, once you scan your cluster, the results are saved as CIDs in the cluster, so you can interact with them in a similar way on how you would scrape other information from the cluster and integrate it into your external tooling. We also understand that for many organizations, privacy is very important, so you can anonymize the data that you send to the LLM. And last but not least, K8sGPT is multimodal, meaning you can either operate it as single tenancy, multi-tenancy, across one cluster or multiple. The choice is up to you.
Thank you, Anais, for giving such a wonderful rundown. I think that you did really good justice to some of the key features that people are excited about the most. Now, we've spoken about K8sGPT very much as sort of an observability add-on, nice to have, CLI, you run, you get some results, great. I think today is where we're really going to shift the philosophy into another direction, which is where we're introducing auto-remediation. So we use guardrails to effectively look at the patching delta that an AI may suggest based on a result. And I'll explain about that a little bit later. But what's so interesting about this change of course is that we've gone from effectively an informational observability tool to now a very tight loop reconciliation in terms of here's an error, I think I know how to fix it based on your organizational knowledge. And to my knowledge at least, this is being done very infrequently, and it often involves quite a large set of different points in the pipeline. You may well have different technologies that bring these together. And never has it been so simple as a one-line command to run this and get it working. So we're really excited about auto-remediation and what that means for the future. Anais had some really good points about tacit knowledge, and it's something that I keep harping onto. But I'm sure many of you will have experiences of being the one person who knows how these three things in sequence work. You know how the 5 different charts all work together. I mean, in some companies you see chart spaghetti, where you have an OCI deploying charts that does OCI, and it's crazy. And so imagine a new starter trying to join a company, to the point of knowledge being this unraveling ball exponentially with technology complexity. This is where we can start to democratize that. And I think we've got all the raw materials here for something very special. So I'm going to talk you through sort of the high-level design. I've got sort of a military-grade laser pointer here, so I'll do my best to use it. K8sGPT, effectively, in the operator mode, looks a bit like this, right? So today, if you were to deploy this into a cluster, as you may well do after this talk, you'll get an operator, nothing exciting there, really. But that operator is really the lifeblood, the heartbeat of keeping the other components working. I've simplified this to be sort of process, right? We're not getting too much into the weeds of the technology. But what happens is the operator runs, it deploys out a K8sGPT deployment. The reason that pattern was chosen is because some of our customers and community use multi-tenancy. You might have vCluster, multi-namespaces per tenant. However, we find that it's really useful as well for being able to start to decouple some of the steps and asynchronous activities. So you've deployed out your K8sGPT. It's a bit like the CLI, effectively. It has analyzers built in. You could even hook it into custom analyzers. You might even probe another cluster elsewhere. You can build an aggregate of data. What then comes back is that you build up this picture of results. The results, as we're going to go into the demo in a moment, show you effectively the output of your inference API. That could be local AI, that could be in Bedrock, that could be in Hugging Face, as we mentioned. That could be anywhere you like. What's important about that is that you've codified that issue against that solution, right? So when a pod of this name, of that deployment, it's hashed, right? So you effectively have a key value lookup for that particular solution, which is going to be powerful, as I'll go on to describe. So what happens at this point with the new auto-remediation workflow, and for folks who aren't familiar with this generally, is that the results then get inspected for their credibility. We look at the results and say, is that actually an issue, or is that just something that you think is an issue? And so we built a series of safeguard kind of guardrails around the auto-remediation dotted line there. We calculate applicability. Let's say, for example, I have a result that says this image is missing. I can then inspect through my knowledge base, through my RAG and my data store, if that image is something that my company knows about. And if it is, I can go on and apply the right fix. In this particular case, it could be that, you know what, that's valid. There's an incorrectly named resource. So what I'm going to go on and do is I'm going to build out what's called a resource tree to figure out what do I need to do to fix this issue. So I mentioned it's a bit like a Git patch, where effectively you've got the delta of change. That's what gets stored in this immutable log. The mutations log will get created when you decide, yeah, I'm going to turn auto-remediation on. I'm going to give it a spin. The mutation is another custom resource that keeps effectively a chronological account of what was your resource, what was the suggested change, what was the applied change, what was the result. And so the way that the mutation works is once the mutation's applied, it will then determine success by looking at the result, which will then get reprobed from the analyzer. If it's successful, the mutation is successfully applied. We use a few different tricks to be sensible around here. We actually make sure that there's a relatively low Levenshtein distance, so in terms of like the patching difference, we also do a few other bits and pieces. But it's super important that people build confidence in this. This isn't the Wild West of, hey, I'm just going to throw things into an AI, see what garbage it comes back with. We're trying to apply this in a very measured and a very careful way. And I'll go on to show you this momentarily. We think that this pattern is so profound and so interesting that we're starting to see it change the way that enterprise customers, contributors, and collaborators are talking to us. They're starting to say, hey, Alex, we've got this really large data lake of textual and ticket information. We're going to run it through our embeddings AI, and we're going to spit it out into this vector DB. We want K8sGPT to consume that to get smarter. And at the beginning, I was like, this feels like it's kind of going outside of the area of my CNCF boundaries here. But actually, what I realized is that is exactly how people want tooling to be used. It needs to be interoperable. And so therefore, we found that this new idiom is becoming very popular. What's happening in a few of the teams that I've been working with is they're describing this kind of workflow. And this is a flywheel, right? This is your traditional kind of SRE workflow, where you have a ticket or an alarm or an incident or a page or the beacons of Gondor, whatever that might be. That will then tell you to wake up at 3 a.m. You typically check your observability systems. You see that there's an issue, there's a fault, there's something to inspect. You mitigate that. You stop the bleeding, right? You fix that thing. It could be in this particular case that something needed restarting, something ran out of resources, who knows. You then update that mitigation, that root cause analysis into the ticket, into the correspondence, the comment, whatever that data source is. Typically, just anecdotally actually, somebody showed me that they're big Jira users, they update their Confluence, they then link it against ticket. It's really great. They've got a really nice little workflow there. But what your SRE probably doesn't know is that some companies are starting to export that data. They're using that, as I said, they're bringing that into a knowledge base, so they're using a RAG potentially, and they are starting to harvest that by embedding that data into a foundational model, Bedrock, whatever, it could be anything else, and then they're pulling that back through into K8sGPT. So what is the implication of this? The implication is really profound, because if I'm a frontline SRE, I'm dealing with stuff, every time I write to this, it's making this bit here get more accurate, right? So I could say, okay, well, I picked on Envoy earlier. That Envoy image is missing. Go to this version. We know it's compatible with this cluster, XYZ. And so therefore, the solution gets a bit smarter. But not only that, it's not just the manual remediation that gets smarter. It's then, if we go back to the previous slide, it's also the auto-remediation gets smarter as well. Because the auto-remediation, again, if you're talking to the same inference API that's probably drawing on the same data lakes and knowledge bases, it's going to make smarter decisions. It's going to start saying, I know how to fix that because my company tells me in this big data lake that I got this stuff to do. So we think this is really exciting, and we think that is really changing the game. So let's just do a quick little demonstration. I'm a real advocate of live demos, so let's go for it. It might be a little bit small at the back, so I'm going to bring it up a few notches. So we're going to just grab this off the internet, and the conference Wi-Fi might be bad. It might be good. And if you're feeling brave and you want to play along, all you need is an AWS secret key and access key in your Zush profile. And oops, let's just delete this because here's one I made earlier. And this is a real test. This is a real proof, actually, that it's a live demo. So let's do it again. There you go. Completely promise you it's a live demo. So there we go. This takes about 2.5 minutes. So while the demo is running, I'm going to jump in and out of resources. I'm going to talk to you about it, just describe what's going on. So you've seen there's a few requisites, Helm, kind, familiar nomenclature to a lot of you, I'm sure. What I'm going to do now is I'm going to talk you through as it all spins up. Very annoyingly, though, my screen here has disappeared, so I'm basing it off the one down there. So what is all this stuff? All this stuff doesn't look good. I don't like stuff going in my cluster. Well, let me talk you through it. The top one is an optional cache. You can turn that on and off in Helm. It's just a cache to keep your prompts saved and your responses. It seemed like common sense to me that you want to hit the API as little as possible. There's also some inherent benefits from the cache when we start to check again our own homework, but we'll talk about that in another session. Below that, you've got the operator, as I described. It's not particularly exciting, although it is the lifeblood of everything goes on. And here is our broken deployment. Some very, very naughty person on a Friday has called this engine XXX, and I have no idea why, right? It's a simple example, but I wanted to make sure we're all on the same page. So what else is happening is the K8sGPT deployment has been triggered. So what does that mean? Well, there is a K8sGPT config. We're used to dealing with this kind of stuff. So what do we see? Oh, laser pointer. What do we see here? Cool. Auto-remediation, true. Resources, these ones. Similarity requirement, 25%. That is a baseline of similarity. That's pretty broad. I could set that to 95%, so there's only a 5% delta of change. And then apart from that, I've got the usual gubbins of things that I've turned on and off. I go back. I'm going to say, oh, well, that missing deployment's still there. Demo's failed, obviously. Well, let's take a look at the mutation. The mutation in progress, similarity score, 27. So it's hit the similarity score requirement. It's applying a delta of change. But I told you there are those guardrails earlier on, right? We only apply stuff and keep it in cluster, and we can then prove that it's fixed the result. So the result has to actually go away for this to then work. So what's all this stuff mean? Well, you can see now a new replica set has come up. And in fact, it's not just a new replica set, it's a new deployment. And there's some inherent benefits to this because it allows us to compare and contrast. We're saving this within the memory banks of K8sGPT. Now, what's really cool there is, oh, cool, I've now got a working deployment. I mean, as I say, you can download this, you can check it out. It fixes it. It's a simple one, as an example, but we go down into here, and I compare and contrast. We've got our fixed one, and I'll just apply, and we've got our broken one. And you can see, when you compare the difference, it's changed. Now, if I go back to my results, I don't think I even had time to show you this one. We can look here and see, hey, what's this? Find more info in Jira ticket cube 123. Right, completely fictitious team, but you get the point, right? We're able to find out where this data comes from. So therefore, this is why we're getting really, really excited. So thank you so much, and I'm very grateful to the demo gods that we had a pretty good run just then. Here you go.
Amazing, thank you. So now that we've seen how auto-remediation works, what K8sGPT does in your cluster, let's look ahead and what does it actually mean for the way that we operate with each other and within our teams, as well as how we operate with our tooling in the future. I saw lots more people come in while we were giving the demo and while we were speaking. So I just want to iterate. Our goal is to run basically zero-touch environments. We should be able to run 50, 100, several hundred clusters with little to no human interaction with those environments. Now, most of our open source tooling in the cloud-native space is not set up to never fail. There will become a point where you have to go manually into environments, identify whether the error is actually correlated to something that has to be fixed manually, or whether there is maybe a more automated, more natural fix to it that will eventually show up. For example, there used to be an issue in Argo CD where basically your application deployments would just hang in a sync loop. It would just be there and not update, even if you've deployed a new version and Argo is just not pulling that into the environment. Now, a quick fix is to go into the cluster and just delete that application deployment. So Argo CD can pull in the healthy version and fix it. You don't want to do something like that across several hundred clusters, right? So what you do is you might write a script, you might create your own operator for that specific problem to address that issue that you identified and that otherwise would have to be fixed manually. Now, as we scale our infrastructure, the need for automated management from tooling such as Argo, such as Crossplane, increases. And similarly, the need for an auto SRE on-call 24/7 increases as well. We need someone who can be right in those environments, who has the knowledge from previous issues, coded in it, and can take action right then. And that's where K8sGPT comes in. So Alex mentioned earlier the knowledge base, the RAG that you can set up that your AI backend is pulling data from. Imagine that's similar to having an open book versus a closed book exam. You can't expect the AI model to know what to do in your specific setup without providing this additional information that you identified as SREs, as you identified the situations, the different issues, and how to remediate them. So once you have that knowledge, you provide it to the AI through the knowledge base, so it can then take long-term actions that you would otherwise take manually. Now, while a lot of organizations promote replacing junior and mid-level engineers with AI tooling, we think differently about it. Making the gap between the knowledge that we share with people in our organizations, as well as that we codify into our tooling, reducing that gap, means that as a junior or mid-level engineer, SRE, is looking at that broken cluster, at that broken workload, it can work together with K8sGPT and use that additional knowledge that K8sGPT is providing to link to other resources to make informed decisions, or that SRE might not be called in the first place because K8sGPT can auto-remediate that issue.
Thank you. I imagine there are a few of you in the crowd who are doing a Columbo right now, being like, well, that's great, but my pattern is GitOps, and I don't work in this method of just push and apply to clusters. And so, yeah, no, I thought of that too. And so I wanted to share with you a little bit about the roadmap this year. And the very next thing, and I promise the very next thing after Parents' Evening tonight, is I'm going to sit down and I'm going to release the branch for auto-remediation GitOps support. So there's a few caveats to GitOps, right? I would need to give you a point of origin for my repositories, but it's entirely possible. The idea here would be that rather than apply the fix directly, we would track it against the PR, watch the PR lifecycle go through, and then the result would complete. After that, Anais mentioned we have 11 AI backends. But the truth of that is each backend has N models, right? Some of them have 30+ models. It is a nightmare supporting it. The interoperability is horrid. So MCP is a really natural next step for us. And that's something we'll be looking to get out in sort of the third quarter of 2025. After that, things get really interesting. And I touched upon it earlier, and you might have seen that similarity score. I think I showed you in the cluster. I think we can do better. I think we can look at that delta, that patch, run it through a separate, highly specific agent for detecting changes in the YAML itself to tell me whether it's safe, right? So if an annotation changes very subtly, we've got to determine, is that safe, right? And so that would obviously need its own context. But I'm committing to getting that out by this year because I think really people need those guardrails to really feel like they can actually turn on auto-remediation because there's a lot of caveats around that. And so this is a really important point for us. And finally, we're going to build out additional core analyzers for Kubernetes resources and APIs we don't fully support yet, like Gateway API, et cetera. So what I'm asking you, we're a completely community-run project. We've got maybe like 3, 6, about 9 core contributors. You could be one. The stack is it's Golang, it's Rust, it's lots of really interesting modular interoperable components. Just using it is really important. Just trying. You don't need to be a coder. Helping us with our docs, being able to say, you know what, Alex, this sucks, and you could have expressed that a bit differently, it'd be so helpful. So, I really believe in putting your money where your mouth is as well. Like, go try it out. There's a little URL, and that just gives you like the Helm and Kind version. You can go onto our website. You can download it with Brew. Check it out. Tell us what works for you. And I'm excited about the next time we come back to KubeCon, hearing about everything that you've been doing with K8sGPT. Thank you so much.
Thank you.